Hello, welcome to my talk. I am Santanu Pal from Wipro AI Lab, Bangalore, India. I am presenting Wipro Translate, which is Wipro AI Submission to Workshop of Asian Translation in 2020. So nowadays, neural machine translation has evolved, promising machine translation paradigm to an established state-of-the-art technology. The state-of-the-art machine translation method are following encoder-decoder framework, and nowadays these frameworks are enhanced to a transformer network which was proposed by Vaswani in 2017. Transformer networks are trained in a supervised manner, relying on paired source target datasets. These are parallel sentence aligned datasets to train the transformer network. So, in this research, we saw how effective preprocessing helps to improve performance of machine translation model, and how synthetic data through back translation from available monolingual data can help in overall translation performance. And also we saw how language similarity can add more onto it in terms of performance. To for our experiment and to find all the three different research questions, we experiment our method with English to Hindi and English to Hindi and Hindi to English machine translations model. So uh, we use the release data sets in WAT, which is IIT Bombay dataset, which is 1.5 million, and WMT dataset, and which is like 273 thousand dataset, and news dataset, and PIB corpus. In this case, it is like 156K dataset, and also PM India datasets is like 56K. So overall, we have 2 million approximate dataset. After removing duplicates, it's we found it is like 1.4 million datasets for training. But these datasets, we notice that these are like a mixed language dataset, so that we remove the mixed language as well as sentences from the data from 1.4 million datasets, and we found finally 961K data are useful for training for our model. So before training, we perform some pre-processing. We perform punctuation normalizations, Moses tokenizations for using Moses tokenizer. We use tokenization, and also for the English side with no escape options, and finally we perform true cases on the source side. Sorry, in this case on the English side, and additionally we use Hindi Marathi parallel data from WMT 2020 similar language tags. For the Hindi side, which is not here mentioned in the slide, we use Indic tokenizer, Indic NLP tokenizer, for tokenizing the Hindi side of the parallel corpus. So our model is following the transformer based transformer architecture, and also this model was prepared using multilingual NMT system, NMT method, uh, using some simple additional token are used at the beginning of each source sentence to indicate the target language by NMT model, which will be translated to. So after pre-processing, we found that uh, our model sorry, after pre-processing, here is some example. In this case, the if you notice here, the raw data is a simple parallel corpus. We use additional token like to Marathi at the beginning of the source sentence. So if for the first cases it is Hindi to Marathi, if it will translate to Marathi, so we add to MR, a token at the beginning of the Hindi sentence, and the target sentence for the Marathis, it will be as it is. For the other case, for similarly we use similar things like Hindi to English and English to Hindi. Uh, for hyperparameter setup, we use 16,000 warm-up step, which is most of the hyperparameter setup is similar to base transformer setting, but in this case we change little bit. We use warm-up step like 16,000, batch size 25k tokens, 32k BPE versions, and maximum allowed sentence length is 256 subwords, and during inference times we use beam size 4. The result is to find how effective preprocessing help to improve the performance. If you see the table, here is the improvement, like for the Hindi to English cases, it is baseline score is 12.83 blue score, but after preprocessing it is like 17.30. uh, so in this case preprocessing is only done only use cleaning and removing the mixed language sentences, but when we use back translations like 5 million English or monolingual data from news, uh, in this case it is like 19.51 blue score. Similarly, this similar improvement we found for English to Hindi directions also. So that we also find that our second research questions, how synthetic data through back translation from available monolingual data can help in overall translation performance. So to find the third questions, how language similarity can add more into onto the performance. In this case, we train a multilingual system, which I have shown in previous slide, the example slide, for multilingual preprocessed data before training. So in this case, X1 is a multilingual system, which is Hindi to English. In this case, it is a single system. So in this case, we achieve 29.58 blue score, and similarly for Hindi to English to Hindi, it is like 22.08 blue score. But X3 is the ensemble of three different X1 models, which was randomly initialized the weights, and it is achieving like 2.80 blue score. So to conclude, we saw how effective pre-processing and back translation and language similarity helps in improving performance, and our system ranked first among all the participants in terms of blue score. Thank you.